My name is Basir. In this video, I will be teaching you exercise 7.2 from chapter 7, coordinate geometry, CBSE 10th class syllabus. Now, we will first derive the section formula. A section formula is a formula which helps you in finding the coordinates of a point which is dividing a line segment joining 2 points in a certain ratio. Now you can see for yourself, we have a line segment AB, and that line segment AB is joining the points x1, y1 and x2, y2, and this line segment AB is being divided by the point P in the ratio m1 is to m2. Section formula helps us in finding the coordinates of such a point which divides a line segment joining 2 points in a certain ratio. Now the points x1, y1 and x2, y2 are known to us, and the ratio, obviously it is known to us. We want to find out the coordinates of point P. For now, let us assume the coordinates of point P are x, y. So how do we derive the section formula? The first thing that we do is we do a little bit of construction here. Let us say this is the x-axis OX, and then let us say this is a y-axis OY, and obviously they are meeting each other at a point O here. Now we draw a perpendicular from point A meeting the x-axis at a point R, and then we draw a perpendicular from point P meeting the x-axis at a point S, and then we draw a perpendicular from the point B meeting the x-axis at a point T, and then we draw a line segment passing through the point A. We draw a line segment AQ which is parallel to the x-axis, and then we draw a line segment PC, obviously passing through the point P. This PC is parallel to the x-axis, and we know that when two lines are parallel to the same line, they will in turn be parallel to each other as well. So AQ and PC, they are both parallel to the x-axis, so in turn they will be parallel to each other as well. So AQ and PC, they are parallel to each other. And then you can see AB is the transversal, which is obviously cutting the parallel lines AQ and BC. Now this angle that you see here, angle A, and this angle that you see here, angle B, they are known as the corresponding angles, and since AQ and BC, they are parallel to each other, the corresponding angles have to be equal. So angle A is equal to angle B since they are the corresponding angles. In a similar manner, you can see here angle C is 90 degrees and angle Q is 90 degrees. So obviously angle Q and angle C, they are each equal to 90 degrees. So now these two triangles that you see here, triangle PCB and the triangle AQP, they are similar to each other under angle similarity criteria. Now when the two triangles are similar to each other, obviously the ratio of corresponding sides has to be equal, which means the left hand side of this triangle by the left hand side of this triangle, which is PB, should be equal to the right hand side of this triangle BC by the right hand side of this triangle, which is PQ. That should be equal to the bottom side of this triangle AQ by the bottom side of this triangle, which is PC. Now since the section formula is not important as per the examination point of view, so if you want to skip it and move on to the exercise directly, feel free to do so by following the timeline in the description of the video. What is AQ going to be? How much do you think AQ is going to be? Now you can see for yourself the coordinates of point B are x2, y2, which means if I move towards the x-axis, it should say x2, and if I move towards the y-axis, it should say y2. The coordinates of point P, we don't know the coordinates of point P. For now, we are assuming that the coordinates of point P are x, y, and we want to find out what is x and what is y, because using the section formula, you can find out the coordinates of a point P, which is dividing a line segment joining 2 points in a certain ratio. For now, we have assumed that the coordinates of point P are x, y. So if we move towards the x-axis, it should say x. If we move towards the y-axis, it should say y. The coordinates of point A are x1, y1. So if you move towards the x-axis, it should say x1. If you move towards the y-axis, it should say y2. Now, What do you think would be the coordinates of point C? What do you think would be the coordinates of point C? I say that the coordinates of point C should be x2 comma y. Why do I feel like in this way? Obviously because from point C, if you move towards x-axis, it says x2, and then if you move towards the y-axis, it says y. So the x coordinate is x2 and the y coordinate is y. Let us find out the coordinates of point Q. What do you think would be the coordinates of point Q? From the point Q, if I move towards the x-axis, it says x, and then if I move towards the y-axis, it says y1. So obviously the coordinates of point Q are going to be x comma y1. Now let us find out how much is BC going to be. I tell you that BC is going to be y2 minus y. How do I know this? Obviously the line segment BC, which is joining the points B and C, is parallel to the y-axis. I told you in part 1 of the video series that if a line segment joining two points is parallel to the y-axis, then the distance between the points is the difference of y coordinates. The y coordinates are y2 and y. So the difference of the y coordinates would give you the distance between the points B and C, because the line segment BC, which is joining the points B and C, is parallel to the y-axis. In a similar manner, what do you think would be PQ? PQ is going to be y minus y1, because obviously PQ is a line segment joining, PQ is the line segment which is parallel to the y-axis. So the difference of y coordinates will give you the distance between the points P and Q. What do you think is the distance between the points A and Q? AQ is a line segment which is parallel to the x-axis. So the difference of x coordinates will give you the distance between the points A and Q. The x coordinates are x and x1. So the difference is x minus x1. In a similar manner, what do you think is PC? PC, line segment PC is parallel to the x-axis. So obviously the difference of x coordinates will give you the distance between the points B and C. So x2 minus x. If you follow this, well and good. If you do not follow this, there is one other thing that you can do here. There is one more thing that you can do here. See, what is RS going to be? How much do you think is RS? Obviously RS is x minus x1. How? From O to S, the distance is x units, and then from O to R, the distance is x1 units. So RS is obviously going to be x minus x1. If this is x minus x1, if RS is x minus x1, this also is going to be x minus x1. So there is one other way in which you can find out AQ, PC, PQ, and then BC. Okay, now that we know the values, let us substitute the values here. In place of AP, what is AP? AP is M1, so let me write M1 here, and then PB is M2, so let me write M2 here. BC is y2 minus y, so let me write y2 minus y, and then PQ is y minus y1, so let me write y minus y1. AQ is x minus x1, so let me write x minus x1 here, and then PC, how much is PC? PC is x2 minus x, so let me write x2 minus x here. Now to find out the value of x, you can compare the x with m1 by m2. Compare this term x minus x1 by x2 minus x with m1 by m2. Let's do that. So I'm going to compare x minus x1 by x2 minus x. I'm going to compare this with m1 by m2. So let's compare that with m1 by m2. Now let's cross multiply them. M2 is going to multiply on the left hand side, and then this thing will multiply the right hand side. So m2 into x minus x1 is equal to m1 into x2 minus x. Now let me multiply and open the bracket. M2 into x, that gives me m2x. M2 into x1, that gives me m2x1. M1 into x2, that gives me m1x2, and then m1 into x, that gives me m1x. Let us take x on one side and let us take this to the right hand side. So what happens here? M2x minus m1x, if I take it to the left hand side, it becomes plus m1x. and then minus m2x1. If I take it to the right hand side, it becomes plus m2x1. So now you can see for yourself, on the left hand side of the equation I have two terms, and in both the terms I have x common. So let me take x common. If I remove x from the first term, I am left with m2, and if I remove x from the second term, I am left with m1 here. The right hand side I'm going to write it as it is, m1 x2 plus m2 x1. Now m2 plus m1, it is multiplying on the left hand side, so obviously it is going to divide on the right hand side. The right hand side I'm writing it as it is for now. m2 plus m1 was multiplying on the left hand side, so obviously it will divide on the right hand side. So I got the x coordinate of the point P as m1 x2 plus m2 x1 by m1 plus m2. Similarly, we are going to get the y coordinate as m1. In y coordinate, instead of x you write y, so this becomes y2, and obviously instead of writing x1 you write y1 by m1 plus m2. So the section formula is going to be m1 x2 plus m2 x1 by m1 plus m2. That's your x coordinate, and then the y coordinate is m1 y2 plus m2 y1 by m1 plus m2. So what is x comma y? X comma y is m1 x2 plus m2 x1 by m1 plus m2, and then m1 y2 plus m2 y1 by m1 plus m2. So using the section formula, we were able to find out the coordinates of the point P, which was dividing the line segment AB in the ratio m1 is to m2. So that's the section formula for us. Remembering the section formula is pretty easy. If here you have 1, here you have 2. If you write 2 here, you write 1 here. That's about it. So it's pretty easy. m1 x2 plus m2 x1 by m1 plus m2. m1 y2 plus m2. If you write 2 here, write 1 here. y1 by m1 plus m2. That is one way of remembering the formula. That's how I personally remember the formula. Okay, so we assumed that the point B was dividing the line segment AB in the ratio m1 is to m2. We took the ratio as m1 is to m2. But then instead of taking the ratio as m1 is to m2, you can take the ratio as k is to 1 also. Why k is to 1? Obviously, you can take it as k is to 1. Why? Because let's say I want to divide this complete ratio by m2. Then what happens? I end up getting m1 by m2 is to m2 by m2. That gives me 1. And then this thing I can consider it as k. So you can take the ratio as k is to 1 also. Instead of taking the ratio as m1 is to m2, you can take the ratio as k is to 1 also. Let me write the section formula for you first, and then in place of m1 is to m2, we'll take the ratio as k is to 1. The section formula is pretty simple. It gives me the point, it gives me the coordinates of the point P, which is dividing the line segment in a certain ratio, right? So the section formula is m1 x2 plus m2 x1 by m1 plus m2, comma, m1 y2 plus m2 y1 by m1 plus m2. Now we'll take, instead of taking the ratio as m1 is to m2, let us take the ratio as k is to 1. So in place of m1, I'm going to write k, and then in place of m2, I'm going to write 1. So let me replace m1 and then write k. Let me replace m2 and let me write 1. 1x1. Okay. So now in place of m1, let me replace m1 and write k. In place of m2, let me write 1. Replace m1 with k, and in place of m2, let us write 1. Replace m1 with k, and then in place of m2, let us write 1. So that is also a section formula if the line segment is being divided in the ratio k is to 1. If the line segment is being divided in the ratio k is to 1, then the section formula becomes kx2 plus x1 by k plus 1, comma ky2 plus y1 by k plus 1. Now, let us say the point P, which is dividing the line segment AB, is exactly in between the points A and B. Let us talk about a special case of section formula, which is known as midpoint formula. Let us say I have a line segment AB, a line segment AB. I know the coordinates of point A as x1, y1, and let us say the coordinates of point B are x2, y2, which are known to me. Let us say the point P, which is dividing the line segment AB, it is exactly in between A and B, which means P is actually the midpoint of AB. Then what is the ratio going to be? The ratio is obviously going to be 1:1. How? Previously we took the ratio as m1:m2. Now since P is lying exactly in between A and B, since P is the midpoint of AB, it cuts AB in the same ratio. Let us say it cuts it in the ratio m:m. Let us say it cuts in the ratio m:m. Obviously m:m can be written as 1:1, isn't it? Why? Because m:m, you can write it as m by m. M into 1 is m. M into 1 is m. 1 by 1 you can write it as 1:1. So obviously you can see for yourself, if the point which is dividing the line segment lies exactly in between the 2 points A and B, then obviously the point is going to divide the line segment in the ratio 1:1. 1:1. Now in the section formula, in place of m1, let me write 1, and then in place of m2, let me write 1. Let me first write the section formula for you. The section formula is pretty simple. Now in place of m1, if I write 1, and then in place of m2, if I write 1, I end up getting something like this. So in place of m1 I wrote 1, and then in place of m2 I wrote 1, and I ended up getting x2 plus x1 by 2, comma y2 plus y1 by 2. You can actually interchange this. You can write x1 first, and then you can write x2 as a second term. You can rearrange the terms. So x1 plus x2 by 2, comma y1 plus y2 by 2 is known as the midpoint formula. Midpoint formula. So if the point P, which is dividing the line segment AB, lies exactly in between the points A and B, it divides the line segment AB in the ratio 1:1. And in the section formula, if you replace m1 with 1 and m2 with 1, you end up getting the midpoint formula as x1 plus x2 by 2, comma y1 plus y2 by 2. Now the midpoint formula is known as a special case of a section formula. In the midpoint formula, what are you really doing? You are taking the average of the x coordinates. You are adding the x coordinates and dividing by 2. So you are taking the average of x coordinates, and then you are taking the average of y coordinates. That's about it. I believe we are now ready to solve the questions from exercise 7.2. Now the first question from exercise 7.2 says, find the coordinates of the point which divides the joint of -1,7 and 4,-3 in the ratio 2:3. Let us say this point is A, and then let us say this point is B. So I have drawn a line segment AB, which is joining the 2 points given to us in the ratio 2:3. Now this ratio, let us take it as m1:m2. Now what do you need to do to find out the coordinates of the point P, which is dividing the line segment AB in the ratio 2:3? You just need to use the section formula. Let us use the section formula and then substitute the values. Let me first write the section formula for you. Now let me substitute the values. Now let me just simplify this. 2 into 4 is 8, plus into minus is minus, 3 into 1 is 3, 2 plus 3 is 5, 2 into minus 3 is minus 6. When you multiply two numbers, make sure you first multiply their signs. Since 2 doesn't have a sign by default, it would have a plus sign. Plus into minus is minus, 2 into 3 is 6, 3 into 7, that gives me 21, 2 plus 3, that gives us 5. 8 minus 3 is 5, by 5 as it is 21, minus 6, that gives me 15, by 5 as it is. Now 5 by 5 by 5 is nothing but 1, because 5 into 1 is 5, 5 into 1 is 5, 5 into 1 is 5, 5 into 3 is 15. So the coordinates of the point which is dividing the line segment joining these 2 points in the ratio 2:3 are 1, 3. Let's move on to the next question. In the next question, it says, find the coordinates of the points of trisection of the line segment joining the points 4, -1 and -2, -3. Let us say I denote this point by the letter A, and then let us say this point is B. So I have drawn a line segment AB, which is joining the 2 points given to us. And we have to find out the points of trisection. What do you mean by trisection? Trisection means the line segment that is given to us, the line segment AB, is being cut into 3 equal parts. Tri means 3, isn't it? 3, T-R-I, tri, that means 3. So the line segment AB is being cut into 3 equal parts. AP, and then PQ, and then QP. Those are the 3 equal parts. So now I want to find out the coordinates of point P and the coordinates of point Q. So if I place 2 points, point P and point Q, on the line segment AB, then these 2 points, point P and point Q, are dividing this line segment AB into 3 equal parts, AP, PB, and then QB. So I want to find out the coordinates of point P, and I want to find out the coordinates of point Q. Now, the point P is dividing the line segment AB in the ratio 1:2. How do I know this? See, if you are at point P, to the left you see only one part AB, and to the right you see 2 parts, PQ and QB. So to the left you have to write 1 because you have 1 part to the left. To the right you have 2 parts, so let us write 2. 1:2. Let us see in what ratio the point Q is dividing the line segment AB. The point Q is dividing the line segment AB in the ratio 2:1, because from the point Q you can see to the left you have 2 parts, so I'm writing 2 here, and to the right you have only 1 part QB, so I'm writing 1 here. So the line segment P is dividing the line segment so the point P is dividing the line segment AB in the ratio 1:2, and the point Q is dividing the line segment AB in the ratio 2:1. Let me first find out the coordinates of point P. How do I find out the coordinates of point P? By using the section formula, obviously. Let's write the section formula. Now, this is your x1, y1, and this is your x2, y2. Since I'm trying to find out the coordinates of point P, the ratio obviously is going to be 1:2. So let me say m1 is 1 and then m2 is 2. So in place of m1 I'm going to write 1, and then in place of m2 I'm going to write 2, and in place of x1, y1 and x2, y2 obviously I will substitute these values. So let us now substitute the values. Now let us simplify this. So the coordinates of point P are 2 comma minus pi by 3. Now let us find out the coordinates of point Q. When you are finding the coordinates of point Q, to find out the coordinates of point Q, you again have to use the section formula. But this time, let us use the ratio as 2:1. So let me first write what is A, what is B, and then let me write the ratio as 2:1. Now, I have written A as x1, y1, B is x2, y2, and the ratio this time we are going to use the ratio as 2:1 because obviously the point Q is dividing the line segment AB in the ratio 2:1, and I now want to find out the coordinates of point Q. Now let us simplify it. So now we can say that the points of trisection are 2 comma minus 5 by 3 and 0 comma minus 7 by 3. I merely substituted the values in the section formula. Let's move on to the question number 3 now. It says to conduct sports day activities in your rectangular shaped school ground ABCD. So I can see a rectangular shaped school ground ABCD, and then they are trying to conduct sports day activities. And to conduct sports days activities, they have drawn lines using chalk powder at a distance of 1 meter each. So they drew a line at a distance of 1 meter from A, and then again at a distance of 1 meter they drew another line, and again at a distance of 1 meter they drew the third line, and again at a distance of 1 meter they drew the fourth line, and so on. And they have placed 100 flower pots along AD. So along AD, 100 flower pots have been arranged at a distance of 1 meter from each other. Now Niharika is running 1/4 the distance of AD on the second line. So that's the second line for us, and Niharika is running 1/4 the distance of AD along the second line, and then she posted a green flag, and then she placed a green flag after running 1/4 of the distance AD. Now the distance AD is obviously 100 meters. Why? Because along AD we have placed 100 pots, and each pot is they have placed pots at a distance of 1 meter each, right? they have placed the pods at a distance of 1 meter from each other. So obviously the distance AD is 100 meters. And how much did Niharika run? Niharika ran 1/4 of this distance. 1/4 of 100 is obviously 25. So she ran 25 meters. So she ran 25 meters. So this distance, she ran 25 meters, and then she posted the green flag. So what would be the coordinates of the point where Niharika placed the flag? The coordinates of the point obviously are going to be 2, 25, because if you move towards the x-axis, it says 2 on the x-axis. Let us say this is the x-axis, the horizontal line AB, and let us say the vertical line AD is our y-axis. So if I move towards the x-axis, it says 2, and obviously if I move towards the y-axis, it should say 25, because obviously she ran 25 meters. So the coordinates of the point where Niharika placed the green flag is 2, 25. Let us denote this point by the letter E. And now Preet runs 1/5 the distance of AD on the 8th line. So on the 8th line, Preet ran 1/5 of the distance AD, and then she placed the red flag. She placed the red flag. So what would that point be? She ran 1/5 of the distance AD, 1/5 of the distance AD. The total distance AD is 100 meters. 1/5 of 100 is going to be 20 meters. Obviously, because 5 into 2 is 10, 0 remains as it is. So 20 meters. She ran 20 meters along AD, and then she placed the red flag. So what would be the coordinates of this point? The coordinates of the point where Preet posted the flag are going to be 8, 20, because obviously if you move towards the x-axis, it says 8 on the x-axis, and then if you move towards the y-axis, it would say 20, because she ran 20 meters along AD, right? Let us say I denote this point by the letter F. Now what do I need to do? I need to find out the distance between both the flags. So I want to find out the distance between EF. I want to find out the distance between EF. How do you find out the distance between the points E and F? You can use the distance formula. Let us use the distance formula. So I want to find out the distance between the point E and the point F. Let us use the distance formula. And what is the distance formula? Distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is x1 y1 and this is x2 y2. Let us substitute and find the distance. So I see that the distance between the two flags is root 61 meters. Now then it says if Rashmi has to post a blue flag exactly halfway between the line segment joining the two flags, where should she post her flag? Now Rashmi wants to post a blue flag right in between the points E and F. So where would she post the blue flag? Obviously you have to use the midpoint formula to find out the midpoint. The point where Rashmi wants to post the flag, the blue flag, is obviously going to be the midpoint of the points E and F. So it's going to be the midpoint of EF. Let us write the midpoint formula. Midpoint formula is x1 plus x2 by 2 comma y1 plus y2 by 2. Now let us substitute the values x1 y1 and x2 y2. So Rashmi has to post the flag. Rashmi has to place the flag at a point 5, 22.5. Now let's move on to the next question here. Now the next question, it says find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by -1, 6. Now previously the ratio in which the point P is dividing the line segment AB was given to us, and we were supposed to find out the coordinates of point P. But this time we know the coordinates of point P and we have to find out the ratio in which the point P is dividing the line segment AB. So what are we going to do? We just need to use the section formula. Let us write the section formula. So this is your x1, y1, and obviously this is your x2, y2. And let us say the ratio in which the point P is dividing the line segment AB is m1 is to m2. So in the formula, m1 would remain m1, m2 would remain m1, m2 would remain m2. In place of x1, y1 and x2, y2, let us substitute these values. Okay, so I substituted the values x1, y1 and x2, y2 in the section formula. In place of m1 and m2, I wrote m1 and m2 itself. I did not change them because I don't know the ratio in which the point P is dividing the line segment AB. So I took the ratio as m1 is to m2. Now, when you use the section formula, what do you get? You get the coordinates of the point P, and the coordinates of point P are already given to me, which means I can equate this thing with -1, 6. Now let us simplify the right hand side. 6 into m1, that gives me 6m1, plus into minus is minus, 3 into m2, that gives me 3m2 by m1 plus m2, and then minus 8m1 plus 10m2 by m1 plus m2. Now I want to find out the coordinates. The ratio m1 is to m2. How am I going to find out the ratio m1 is to m2? You can equate the x coordinates, or you can equate the y coordinates. It is your personal choice. Let us say I equate the x coordinates. Then what am I going to get? Let me equate the x coordinates for you. So 6m1 minus 3m2 by m1 plus m2, that's going to be equal to -1. I have equated the x coordinates, but then if you can equate the y coordinates also, it is your personal choice. Now what do we end up getting? 6m1 minus 3m2 is equal to m1 plus m2 is dividing on the left hand side, so obviously it is going to multiply on the right hand side. So 6m1 minus 3m2 is going to be equal to minus m1 minus m2. Let me take m1 to one side and then m2 to the other side. 6m1 plus m1 is going to be minus m1 minus 3m2. If you take it to the right hand side, becomes plus 3m2. So what do we end up getting? 6m1 plus 1m1 would give me 7m1. 3m2 minus 3m2 minus m2, that gives me 2m2. So obviously m1 by m2 is going to be 2 by 7. m2 was multiplying on the right hand side, so it is dividing on the left hand side, and then 7 was multiplying on the left hand side, so it is dividing on the right hand side. So I get the ratio m1 is to m2 as 2 is to 7. Obviously m1 by m2, you can write it as m1 is to m2. I hope you know this. A by b, you can write it as a is to b, right? In a similar manner, m1 by m2 is nothing but m1 is to m2. 2 by 7 is nothing but 2 is to 7. So the ratio is 2 is to 7. The ratio in which the point P minus 1, 6 is dividing this line segment is 2 is to 7. Now instead of taking the ratio as m1 is to m2, you can actually take the ratio as k is to 1 also. You can take the ratio as k is to 1 also. You could have taken the ratio as k is to 1. Let me try to take the ratio as k is to 1 this time. So in place of m1, I am going to write k, and then in place of m2, I am going to write 1. Let's do that for the entire formula. In the entire formula, m1 would be replaced by k, and then m2 would be replaced by 1. So minus 1 comma 6 is equal to 6k minus 3 by k plus 1, and then minus 8k plus 10 by k plus 1. I told you you can equate the x coordinates or you can equate the y coordinates. It is your personal choice. Let us say I want to equate the x coordinates. What happens when I equate the x coordinates? 6k minus 3 by k plus 1 is equal to minus 1. Let us multiply this to the right hand side. So I end up getting 6k minus 3 is equal to minus 1 into k plus 1. So 6k minus 3 is equal to minus k minus 1. Let me take k on one side, and let me take the numbers on the right hand side. So 7k is equal to 2. I'm getting the value of k as 2 by 7. I'm getting the value of k as 2 by 7. Now I took the ratio as k is to 1. I took the ratio as k is to 1. In place of k, what I'm going to do, I'm going to write 2 by 7. Now to get rid of the 7 from the denominator, you can multiply this ratio by 7. What happens when you multiply the entire ratio with 7? Obviously, you get rid of the 7 from the denominator, and then you end up getting 2 is to 1 into 7 is 7. The ratio as 2 is to 7. So you again ended up getting the ratio as 2 is to 7. So the ratio in which the point 1 comma 6 is dividing the join of points minus 3 comma 10 and 6 comma minus 8 is 2 is to 7. So there are two ways in which I showed you how to do this. You can take the ratio as m1 is to m2, or you can very well take the ratio as k is to 1. It's your personal choice. Now question number 5 says, find the ratio in which the line segment joining 1 comma minus 5 and minus 4 comma 5 is divided by the x-axis. So I have to find out the ratio in which this line segment is being divided by the x-axis. And then I also have to find out the coordinates of the point of division. So what do I do here? See, in the question it clearly says that I have to find out the ratio in which this line segment AB is being divided by the x-axis. On the x-axis, you know that the y-coordinate is 0. So you can take the point on x-axis as x comma 0, because on the x-axis the y-coordinate obviously would be 0. I don't know the ratio in which this point P is dividing the line segment AB. So I can take the ratio as k is to 1, or else I can take the ratio as m1 is to m2. That is our personal choice. That is our personal choice. Let me use the ratio as m1 is to m2. You can try using the ratio as k is to 1 also. Let me first write the section formula. Let me now substitute the values. So this is x1, y1, and obviously this is x2, y2, and the ratio is m1 is to m2. So let us substitute the values here. m1 and m2, obviously they remain same. In place of x2 and x1, let us substitute, in place of x1, y1 and x2, y2, let us substitute the values. What do I get when I use the section formula? Obviously, when you use the section formula, you get the coordinates of a point which is dividing a line segment in a certain ratio. And I have the coordinates of the point as x comma 0. So I have to equate this with x comma 0 because I'm assuming that the point on the x coordinate, the point on the x axis is x comma 0. Obviously, because on the x axis the y coordinate is 0, and that's the reason I'm assuming that the point on the x-axis is x comma 0. Now what do I do? Let us simplify the right hand side. Now what do you do? Let us equate the corresponding coordinates. Now I would be a fool if I equate the x coordinates. Why? Because I don't know the ratio m1 is to m2 and I don't know what is the value of x. So it's actually a foolish idea to equate the x coordinates this time. So instead we will equate the y coordinates. Let us equate the y coordinates. Let us equate the y coordinates. m1 plus m2 is dividing on the left hand side, so obviously m1 plus m2 would multiply on the right hand side, and I end up getting 5m1 minus 5m2 is equal to 0 into anything is 0. So obviously 5m1 is equal to 5m2 minus 5m2. If it goes to the right hand side becomes plus 5m2, and then I can write m1 by m2 is equal to 5 by 5. m2 is multiplying on the left hand side, so it is dividing on the left hand side, and then this 5 I took it to the right hand side. Since it is multiplying on the left hand side, this 5 would divide on the right hand side. So I end up getting m1 by m2 as 1 is to 1. 5 into 1 is 5, 5 into 1 is 5, so 1 by 1. So the ratio I'm getting it as 1 is to 1. Now that I got the ratio as 1 is to 1, it is easy for me to find out the value of x. How can I find out the value of x? Now you can compare the x coordinates. You can compare the x coordinates. In place of m1 and m2, let us write 1 and 1. In place of m1, let us write 1. In place of m2, let us write 1. So let me equate the x coordinates this time. So minus 4m1 plus m2 by m1 plus m2. The x coordinate here, this x coordinate is going to be equal to this x coordinate, which is x. And in place of m1, I'm going to write 1. In place of m2, I'm going to write 1. Obviously, because m1 is to m2 ratio, we got it as 1 is to 1. Now what happens? Minus 4 plus 1 by 1 plus 1 is nothing but 2. So I'm getting the x value as minus 3 by 2. So the point on the x-axis, which divides the join of the points 1 comma minus 5 and minus 4 comma 5 is going to be minus 3 by 2 comma 0. Previously I took the point on x-axis as x comma 0. Now I know the value of x, so in place of x let us write minus 3 by 2 comma the 0 as it is. So the point on the x-axis which divides the line segment AB is minus 3 by 2 comma 0. Let's move on to question number 6. Question number 6, it says if 1 comma 2, 4 comma y, x comma 6 and 3 comma 5 are the vertices of a parallelogram taken in order, find x and y. So I have written the coordinates given to me in a particular order, which means I wrote it continuously a, b, c, d. I took this as A, this coordinates as B, this point as C, and this point as D, and I wrote all those points continuously A, B, C, D. You can actually start from anywhere. Let us say I want to start from here. If I write A here, then B would be this, and then C would be this, and then D would be this. Just write it in a continuous manner. Now it says that those are the vertices of a parallelogram, and I am supposed to find out the value of X and the value of Y. You know that in a parallelogram, the diagonals bisect each other, meaning the diagonals actually cut each other into two equal halves. Isn't it? In a parallelogram, the diagonals bisect each other. The diagonal AC and the diagonal BD, they bisect each other, which means they cut each other into two equal halves. Let us say the diagonals are meeting each other at the point O, then obviously the diagonals of a parallelogram, they bisect each other, meaning they cut each other into two equal halves. So this half and this half is going to be equal. AO and OC is going to be equal. In the same manner, OD and OB are going to be equal. So you can see for yourself, the point O is actually the midpoint of the diagonal BD, and the point O is also the midpoint of the diagonal AC. So I can say that the midpoint of the diagonal AC and the midpoint of the diagonal BD are the same point O, which means the midpoint of AC diagonal and the midpoint of BD diagonal, they are equal. So I can write here midpoint of the diagonal AC is equal to midpoint of the diagonal BD. And what is the midpoint formula? Midpoint formula is x1 plus x2 by 2 comma y1 plus y2 by 2. Let me write the midpoint formula. x1 plus x2 by 2 comma y1 plus y2 by 2. That's a midpoint formula. Let me write the midpoint formula on the right hand side also. Now for the diagonal AC, this is x1 y1 and this is x2 y2. So in place of x1 y1 and x2 y2, let me substitute these values for the diagonal AC. And for the diagonal BD, the x1 y1 and x2 y2 values are obviously going to be these. For the diagonal BD, this is x1, let us say this is x1 y1 and this is x2 y2. So in place of x1 y1 and x2 y2, let us substitute 4 comma y and 3 comma 5. And then let us simplify them a little further here. Now let us compare the corresponding coordinates to find out the value of x and y. To find out the value of x, let me compare the x coordinates. So let me compare the x coordinates, which means 1 plus x by 2 is going to be equal to 7 by 2, and I can actually get rid of x 2 and 2 from the denominators. Why? Because obviously 2 is dividing on the left hand side, so 2 would be multiplying on the right hand side, isn't it? And then 2 from the numerator and 2 from the denominator, they actually cancel out each other eventually. So I would be left with just this. So x is going to be 7 minus 1 plus 1. If you transpose it to the right hand side, becomes minus 1. So x value is 6. Now to find out the value of y, let me compare the y coordinates. So 5 plus y by 2 is equal to 4. 5 plus y is equal to 2 into 4, which is 8. Y is going to be 8 minus 5, which is 3. Therefore, the value of x is 6 and the value of y is 3. Let's move on to the next question. Now the question number 7, it says, find the coordinates of a point A where AB is the diameter of a circle whose center is 2 comma minus 3 and B is 1 comma 4. So I've drawn a circle for you, and then we have AB, which is the diameter of the circle. Obviously the diameter of a circle passes through the center of the circle. The center of the circle is already given to us as 2 comma minus 3, and then one end of the diameter is given as 1 comma 4, and I want to find out the coordinates of the other end of the diameter. Let us say the coordinates of the other end of the diameter are x1, y1. I don't know the coordinates of the other end of the diameter, so let us say the coordinates of the other end of the diameter are x1 comma y1. Now you know that the center of the circle, it lies exactly between the 2 points A and B, because A and B are the end points of the diameter. The center, which I am denoting by O, it lies exactly between the end points of the diameter, which means O, the center of the circle, is the midpoint of AB, isn't it? Center of the circle, which I'm denoting by the letter O, is equal to the midpoint of diameter AB. What are the coordinates of O? The coordinates of the center are given to me as 2, -3, and let me now use the midpoint formula. What is the midpoint formula? It is x1 plus x2 by 2, y1 plus y2 by 2. Now this is our x1, y1, and this is our x2, y2. Let us substitute the values in the midpoint formula. Now to find out x1, let me compare the x coordinates. Two into 2 is 4, obviously, so x1 is going to be 4 minus 1, which means x1 is going to be 3. To find out the value of y1, let me compare the y coordinates. So y1 plus 4 by 2 is equal to -3. y1 plus 4 is equal to 2 into -3, which is -6. y1 is equal to -6 minus 4. Obviously, plus 4, if it goes to the right hand side, it becomes -4. So y1 is going to be -10. So the coordinates of the other end of the diameter are going to be 3, -10. Now question number 8, it says if A and B are -2, -2 and 2, -4 respectively, find the coordinates of P such that AB is equal to 3/7 AB and P lies on the line segment AB. So I have drawn a line segment AB whose coordinates are already given to us, and now it says P, the point P lies on the line segment AB. So I've mentioned a point P which is lying on the line segment AB. Now I want to find out the coordinates of the point P. When can I find out the coordinates of point P? I can find out the coordinates of point P if I know the ratio in which this point P is dividing the line segment AB. Do I know the ratio in which the point P is dividing the line segment AB? I don't know the ratio yet. But then there's a little hint that is given to us to find out the ratio in which the point P is dividing the line segment AB. And what would be that ratio? The ratio would be AP is to PB, isn't it? AP is to PB. The ratio in which the point P divides the line segment AB is actually AP is to PB. So let us find out how much is AP is to PB. I can find out AP is to PB by making use of this hint here. It says AP is equal to 3/7 of AB. Now I actually need AP and PB, but here I have AP and AB. But you know that AB can be written as AP plus PB, isn't it? The line segment AB, the complete line segment AB, it is divided into two parts, AP and PB. So AP plus PB, that should give me AB, isn't it? So AB, I'm going to replace that with AP plus PB. Now 7 is dividing on the right hand side, so 7 will multiply on the left hand side, and then I end up getting 3 into AP plus PB on the right hand side. Let me multiply by 3 and open the bracket. So what do I end up getting? 3 into AP is 3AP, and then 3 into PP is 3PB. So 7AP plus 3AP, if I take it to the left hand side, it becomes minus 3AP, and on the right hand side 3PP is remaining. 7AP minus 3AP is 4AP, that is equal to 3PB. Now this thing I can write it as AP by PB is equal to 3/4, because PB was multiplying on the right hand side, so I divided it on the left hand side, and then 4 was multiplying on the left hand side, so I divided it on the right hand side. So I am now getting AP is to PB as 3:4. I want to find out AP. I wanted to find out AP is to PB, and I got it as 3:4. So now I know the ratio in which the point P is dividing the line segment AB. What is the ratio? The ratio is 3:4. Now that you know the ratio, all that you need to do is just use the section formula. In place of x1, y1 and x2, y2, substitute these values. In place of m1, you write 3. In place of m2, you write 4, and you would get coordinates of the point P. This is something that you can try by yourself. Please write the section formula, substitute the values, and you will end up getting the coordinates of the point P. Now in question number 9 it says, find the coordinates of the points which divide the line segment joining -2, 2 and 2, 8 into 4 equal parts. 4 equal parts. So let us say I take this as point P, this as point Q, and this as point R. Let us say these three points are dividing the line segment AB into 4 equal parts. You can see for yourself, AP, PB, and QR and RB. Those are the 4 equal parts. Now I want to find out the coordinates of point P. I want to find out the coordinates of point Q. I want to find out the coordinates of point R. How am I going to do this? See, the point P is dividing the line segment AB in the ratio 1:3. How? To the left of P I see one part. To the left of P I just see one part, AB, AP, and then to the right of P I see 3 parts, 1, 2, 3. So obviously the point P is dividing the line segment AB in the ratio 1:3. Let me get rid of these things here. Let me go through this once again. So the point P is dividing the line segment AB in the ratio 1:3, because to the left of P I see one part and to the right I see 1, 2, 3, 3 parts. The point Q is dividing the line segment AB in the ratio 2:2. How? To the left I see 2 parts and then to the right I see 2 parts. So 2:2. But then 2:2 can be written as 1:1. You can write this as 1:1 because 2 into 1 is 2, 2 into 1 is 2. So you can write it as 1:1. You can take the ratio as 1:1 here. And then the point R is dividing the line segment AB in the ratio 3:1, because to the left of R I see 1, 2, 3 parts. To the right I see 1 part. So 3:1. Now all that you have to do is you need to find out the coordinates of point P, coordinates of point Q, and coordinates of point R. How are you going to find out the coordinates of point P? You have to use the section formula. Take this as x1, y1, this as x2, y2, and the ratio as 1:3. When you take the ratio as 1:3, you get the coordinates of point P. The next time, again use the section formula, but take the ratio as 1:1. You would end up getting the coordinates of point Q. And again, you have to use the section formula for the 3rd time by taking the ratio as 3:1, and you will end up getting the coordinates of point R. This is something that I want you all to try by yourself. And then let me know the answer in the comment section. If you face any difficulties, please do let me know in the comment section. Let's now move on to the last question of this exercise. It says, find the area of a rhombus if its vertices are 3, 0, 4, 5, -1, 4, and -2, -1 taken in order. And it gave me a hint also. Area of a rhombus is half the product of its diagonals. Let me draw a rhombus for you. Let us say that is our rhombus, and I'm now going to take the coordinates in an order, which means I'm going to write them continuously. Let us say I denote this point as A, this as B, and this as C, and this as D. Now let me write them in order: A, B, C, D, continuous manner. It doesn't really matter where you start writing from. Let us say you start writing from here, so you write A, B, C, and D just in a continuous manner. A is 3, 0, B is 4, 5, C is -1, 4, and D is -2, -1. I believe you know how to find out the area of a rhombus, right? Area of a rhombus is half into D1 into D2. D1 and D2 are the diagonals of the rhombus. So half into product of the diagonals. Let us find out. Let us say this is D1. The diagonal BD, let us say that is D1, and then the diagonal AC, let us say that is D2. Now how do I find out the diagonal D1? By using the distance formula. Use the distance formula, find out D1, and use the distance formula, find out D2, and then substitute the values here, and then let me know the answer. I would like to stop the video here because it has been a very lengthy video. I do not want to use the distance formula in finding the distance BD and the distance AC. Obviously, it is something that you can do it by yourself. Thank you for staying with me till the very end of the video. I look forward to see you all in the next video. Have a great day ahead. Until then,